Welcome to our virtual demonstration of an automated robot cell, fully visualized and controlled in Unity, using a MetaQuest 2 headset and the URSim simulator. This entire demonstration was developed as part of the virtual reality lecture at Hochschule Karlsruhe within the RKIM Masters program. Here you can see our production setup. A turbine workpiece arrives via the input conveyor. Once in position, a UR20 robot arm picks it up and places it into a CNC milling machine for processing. After machining, the finished turbine is removed by the robot and transferred to an output conveyor, ready to be transported away. Now, let's switch into the perspective of a user inside the VR environment. From here, the operator can freely move around the cell, interact with its elements, and control the process. Here we have a handheld control panel, which provides full access to the cell operations. With it you can start and stop the process and the robot itself, open the safety door, engage the emergency stop, reset the entire system, operate the conveyors manually, and enable a tracker which traces the TCP and visualizes the robot's tool center path. Before entering, the user first has to open the secured fence door using the panel interface. For safety reasons, this is only possible when the process is stopped. Once inside, here you can see the conveyors can be started or stopped individually to observe the material flow. At the center of our system is our robot, a UR20 cobot from Universal Robots. It's fully simulated in URSim with real-time interfacing to Unity and controlled via a virtual PLC inside our application. We now start the full production cycle. With the process initiated, the conveyors start moving the workpieces. Once a workpiece is in place, the robot executes its routine, picking it up from the conveyor belt and placing it into the mill. The finished turbine is then placed on the next conveyor belt. We are able to stop the system at any moment. The current turbine is completed and transported away. Afterwards, all processes come to a halt. By activating the TCP tracker, we can visualize the exact movement path of the robot, following the movement with our own eyes. It's a good solution for teaching and debugging, and in general for analyzing and understanding the process. But what if, you might ask, simply stopping the process is not enough? Imagine a troublemaker, ignoring safety protocols and gaining access to the cell while it's operating. Before the robot can cause any harm to the intruder, we can quickly hit the emergency stop. Immediately, all movements freeze and the system enters a safe state. In a real-world setting, an operator would now have to manually guide the robot back to its home position and prepare all the machines. But here in the simulation, a simple reset function and a button on the panel to move the robot back restores the system and the robot quickly, setting the cell ready for its next operation.